To linear optimization, we're going to do an example of single-stage simplex. So we will use this example today. I'm going to minimize negative 3x1 minus 2x2 plus x3 minus 2x4 subject to these constraints. Again, all of our variables are non-negative. And I have this plus x5, plus x6, plus x7, plus x8. These are actually realistic in the sense that you can think of them as slack variables, where if I had removed these and put less than or equal to's on this side, this is the standard form linear program that would be output from this example. So now what we need to do is convert this into a tableau and start computations there. Alright, we've now initialized the tableau with our matrix A, with our vector B, and our vector C, and the 0 optimization value. But also observe that it's already diagonalized in terms of our slack variables. We already have the identity matrix here. So our basic feasible solution is x5 equals 8, x6 equals 3, x7 equals 4, and x8 equals 6. However, our optimization function is 0 because all of the variables corresponding to non-zero cost have value 0 in this basic feasible solution. So what we need to do now is we need to select a column with negative relative cost. And I like to look for the one with maximum absolute value while still being negative. So this negative 3 is the most negative relative cost, which means that I want to pivot at column 1. So what we need to do is compute theta 0. And the way to do it is to look for the positive entries here. So I see 8 over 1, 3 over 1, and 6 over 1. This is the winner. So we're going to circle that place. That's where we're going to pivot. So we're going to pivot at x1 at x2, 1. So I'm replacing the second basis element with the first column. And now I need to perform row operations such that this is a standard basis vector, that this is the only non-zero entry in the matrix. And we're going to perform those row operations to make a new tableau below. Okay, now let's perform these row operations. Let's first off see that I need to clear out this negative 3. So I need to add 3 of row 2 to row 0. I also need to subtract row 2 from row 1. And finally, subtract row 2 from row 4. So these are the row operations we need to do, so let's fill them out. I've now computed those row operations, so now we are diagonalized with respect to the new basis. Our first basis element is x5, our second is x1, then x7, then x8. So that's performed one step through the loop of the simplex algorithm. Now again, we look at the relative costs, and we see, oh look, I have a negative 5 here. That means that I still can select this column to do my pivot. So I want to pivot on this column, which means I want to add x2 to the basis. And I want to again compute theta 0. And what I'll do is I look at these entries, I look at the ones that are strictly above 0. So I have 5 over 1, 4 over 1, and 3 over 3. 3 over 3 is equal to 1, so this is our lowest number there's where you want to pivot. To pivot on x2 and x8. So I need to replace x8 with x2. So now we want to perform this pivot. Now we want to perform this pivot by performing row operations up to here. And remember, I want to make this position be a 1 and everything above it be a 0. So the first thing we want to do is divide everything in this row by 3, which is actually the value 1. So now that we've cleared out that out, so we have a 1 in that position, we're going to use this version of row 4, and I'm going to cancel that out everywhere else. Specifically, I want to subtract it from this row, add it to this row, subtract it from this row, and then add 5 times it to this row. Now we've completed the tableau arithmetic very carefully. And we see, looking at our relative costs, that all of our relative costs are non-negative, which means that we cannot improve minimizing our cost by doing another switch, by doing another pivot, which means that we are at the optimal solution. So we would write opt equals yes and halt our algorithm. We can then reconstruct our basic feasible solution from these values. Remember, we have from our basic variables, x5 equals 4, x1 equals 4, x7 equals 3, x2 equals 1, and every other variable is equal to 0. And our cost is negative 14. Remember, this is the negative of our cost function. So negative 14 is the best we can do, and that's, remember, we're trying to minimize. We started off with 0, we moved up to, now we had negative 9, and now we have negative 14. This ends our example and this set of videos.